In this video, I am going to discuss about the different types of the AC circuit and in which circuit containing the inductance and capacitance means LC circuit. And in the previous video, already I have discussed about the circuit containing inductance and resistance, LR series circuit, CR series circuit, and now today I am going to discuss about the LC series circuit here. Let an alternating voltage V is equal to V naught sine omega t be applied across a circuit in which a inductor of inductance L and a capacitor of capacitance C are joined in series. Let the voltage across this inductor is VL and potential or voltage across this capacitor is VC. Since in alternating current VL and VC means alternating current and alternating voltage is taken as a vector. So the vector sum of VL and VC is equal to the applied EMF. Here, remember this, here I am taking the vector sum of VL and VC. So when you will draw the phasor diagram, since in the series circuit, current in both is same, so let I be the current in this one. So when you will draw the phasor diagram for this combination, so first you will draw this for suppose current I, and since current is same in both, and first if suppose there is only inductor, no capacitor, and if the circuit contains only inductor, then voltage across this inductor is always leads the current I by phase angle of 90 degree, means VL will go upward. And when circuit contains pure capacitor or perfect capacitor, then in that case the voltage across the capacitor is lags behind the current by phase angle of 90 degree. So this one is VC. Means this angle, how much here? 90 degree, and this one is also 90 degree. The voltage across the inductor, which is VL, leads the current I by phase angle 90, and the voltage across capacitor lags behind the current by phase angle 90 degree. Now you see here, in this case, your aim is to find the vector sum of VL and VC, and the vector sum of VL and VC is equal to the applied voltage. So here VL and VC, what is the angle between them? 180 degree. It means both are opposite to each other. And if the two vectors are opposite to each other, then their resultant vector is equal to greater vector minus a smaller vector. And since you are not sure about this one, which one is more, VL is more than VC or VC is more than VL, so you can write applied net voltage V is equal to difference of these two, VL difference VC. VL difference VC means if VL is greater than VC, so you will take VL minus VC. And if VC is greater than VL, then you will take VC minus VL. It means the applied voltage V is equal to VL difference VC. And as you know, VL is equal to I into XL. Already I have told you in the previous video. Like V is equal to I into R. So potential difference across inductor VL is equal to I, and which factor oppose the current in this inductor? Inductive reactance. That one is denoted by IXL, and VC is equal to I into XC. So you can write here V is equal to IXL minus IXC, or you can write this is equal to I, and here XL minus XC. XL difference XC. Difference XC. So in this way you can say applied voltage V is equal to I XL difference XC, or I is equal to, or you can say R I is equal to V upon XL difference XC. I is equal to V upon XL difference XC. And by Ohm's law, I is equal to V upon R. It means this term XL difference XC is the effective resistance of that circuit. But that effective resistance is called its impedance, not resistance. When you will compare or when you will apply the Ohm's law here, since applied voltage is V, current you have taken in the circuit is I. So I is equal to V upon R. It means this one is the equivalent resistance of this circuit, but this one is not called equivalent resistance. This one is called its impedance. So XL difference XC is called the impedance of this circuit, and that is denoted by Z. So you can write Z is equal to XL difference XC. It means the impedance of LC circuit is XL difference XC. Means if XL is greater than XC, then you will take XL minus XC, and if XC is greater than XL, then you will take XC minus XL. So in this way you can find out the impedance of this LC series circuit. Already I have given the formula for finding the impedance of LR circuit, CR circuit, and now here the formula for finding the impedance of LC circuit. And now you see here, if this point is very very important, if XL is equal to XC, be careful at this point. इसको बहुत ध्यान से देखिएगा. If XL is equal to XC, it means if inductive reactance is equal to the capacitive reactance, then in this case XL difference XC becomes 0. अगर ये दोनों बराबर होगा, इनकी वैल्यू कितनी आ जाएगी? 0. इसका मतलब Z की वैल्यू क्या आ जाएगी? 0. It means here XL difference XC means Z becomes 0, or this quantity becomes 0, then this current becomes infinite. So if XL is equal to XC, then Z is equal to 0, and current becomes infinite. And when current becomes infinite in the circuit, then this one is called the condition of electrical resonance. This is called condition of electrical resonance. So if anybody asks you what is the condition of electrical resonance, so under the condition of electrical resonance, XL is equal to XC. And in this case, if anybody asks you what is the impedance of the circuit, so impedance of the circuit is 0. What is the current in the circuit? Current in the circuit becomes infinite. So in electrical resonance condition, XL is equal to XC. And at place of XL you can write omega L, and at place of XC you can write 1 upon omega C. It means omega square LC is equal to 1, or omega square is equal to 1 upon LC, and omega is equal to 1 upon root LC. At place of omega in terms of frequency, what can you write? Omega is equal to 2 pi f. So 2 pi f is equal to 1 upon root LC. It means f is equal to 1 upon 2 pi root LC. And in this way you can find the resonant frequency. This f is called resonant frequency, and this resonant frequency f is equal to 1 upon 2 pi root L into C. Now if anybody asks to you, since 2 pi is the constant, if anybody asks to you what is the dimension of 1 upon root LC, so dimension of 1 upon root LC is same as the dimension of frequency, and dimension of frequency is t to the power minus 1. It means the dimension of 1 upon root LC is t to the power minus 1. If anybody asks to you what is the dimension of root LC, so dimension of root LC is 1 upon f, and 1 upon f means time period, and its dimension is what here? T. So several times such type of the question we also ask in your competitive exam, what is the dimension of 1 upon root LC, or what is the dimension of root LC. So on that time, direct with the help of this formula you can find out the dimension. No need to find no need to put the dimension of L and C and then you calculate it. It becomes very lengthy and there is more chance to mistakes here. So simply you can find with the help of this one. So if anybody asks to you what is the electrical resonance condition, XL is equal to XC. What is the resonant frequency? F is equal to 1 upon 2 pi root LC. So this F is called the resonant frequency of the circuit here. Now, the last case which I am going to discuss here, that case is very, very important because already I have discussed the LR series circuit, CR series circuit, LC series circuit, and now the last circuit, which one is what here? LCR. Means the circuit containing inductance, resistance, and capacitance in series. That one is called LCR series circuit. So, in this circuit, LCR are connected in series. Last one is what here circuit containing the inductance, resistance and capacitance in series, LCR series circuit. So LCR. Let an alternating voltage V is equal to V naught sin omega t be applied across a circuit in which inductor of inductance L, capacitor of capacitance C, and resistance of resistance R be connected in series. Let the voltage across the inductor is VL, voltage across capacitor is VC, voltage across resistance is VR. And since all these three LCR are connected in series, so current in LCR will be same. So when you will draw the phasor diagram, and you can say here VL, VC, VR, their vector sum. I am not saying here algebraic sum because in the alternating current in this chapter, when you will draw the phasor diagram, then alternating current and alternating voltage are taken as a vector. So the vector sum of VL, VC and VR is equal to applied voltage V. So when you will draw the phasor diagram, since current is same in these three, so first we will draw for current I. And forget this one, you take R. And when circuit contains only resistance, then voltage across this resistance and current in this one is in the same phase. It means this one is current I. So voltage across this resistance VR and I both are in same phase. Next, when the circuit contains only inductor, forget this one, isko bhul jao. Then when the circuit contains only inductor, then the voltage across the inductor lead the current I by phase angle 90 degrees. Current is this one, it means the voltage across inductor VL will be goes upward. Means the potential across this inductor or the voltage across the inductor lead the current I by phase angle 90 degrees. And when circuit contains only capacitor, then the voltage across this capacitor lags behind the current by phase angle 90 degrees. So VC will be goes downward by what angle? 90 degrees. So now you have three vectors. VR, VL, VC, and our aim is to find their vector resultant. Resultant means a vector resultant of VR, VL and VC. And this resultant is equal to what here? Applied voltage V. So for this purpose, how can you find it? Suppose for a minute, I am taking VL is greater than VC. But it not necessary. I am taking here, suppose VL is greater than VC. Then the resultant of VL and VC, since the angle between them is 180 degree, so resultant of VL and VC, you can write VL minus VC. If VL is greater than VC, then their resultant VL minus VC, and this resultant VL minus VC will act in the direction of VL. क्यों? क्योंकि हमने VL को ज़्यादा लिया है. तो suppose this one is VL minus VC. ये इतना हो. अब VL और VC का रिजल्टेंट हमने ले लिया VL माइनस VC, जो कि VL के डायरेक्शन में है, क्योंकि VL को हमने ज्यादा लिया है. अगर VC को आप ज्यादा लेते तो आप लिखते VC माइनस VL देन डाउनवर्ड. सो नाउ रिजल्टेंट ऑफ VL एंड VC इज VL माइनस VC. नाउ VL माइनस VC और VR, अब इसका रिजल्टेंट निकालिए. सो दिस एंगल बिटवीन देम इज 90 डिग्री. सो देयर रिजल्टेंट इज गिवन बाय दिस वन. V, and this V is equal to root VR square plus VL minus VC whole square. You can write this one here, or you can write V square is equal to VR square plus VL minus VC whole square. Also you can write like this one. And this one is applied voltage V. and suppose this applied voltage V leads the current I by phase angle phi. इसको क्योंकि ये ऊपर की तरफ जा रहा है, मान लेते हैं ये अप्लाइड वोल्टेज V करंट I से phi डिग्री क्या कर रहा है, लीड कर रहा है. So from here you can say applied voltage V, or you can write V square is equal to, from here V square is equal to VR square plus VL minus VC. As you know, VR is equal to IR, VL is equal to IXL, and VC is equal to I into XC. So now you will put the value here. Then you can write V square is equal to I square R square plus I square XL square minus I square XC square. Or you can write V square is equal to, take I square common in all, and here you can write R square plus XL minus XC. XL, here VL, IXL, and this one is IXC, and this one is whole square. Sorry, this as VR square, I square, R square plus VL minus VC means IXL minus IXC whole square. और यहाँ से I square बाहर I करेंगे, तो I square को सबको बाहर ले लीजिए, तो यहाँ मिल जाएगा R square plus XL minus XC whole square. So from here you can say I square is equal to V square upon R square plus XL minus XC whole square. So I square is equal to V square upon R square plus XL minus XC whole square, and you can say I is equal to V upon root R square plus XL minus XC whole square. R square plus XL minus XC whole square. And again you apply the Ohm's law. By Ohm's law, I is equal to V upon R. It means this term will give what here? Effective resistance of the circuit. But this one is not called effective resistance. इसको क्या नाम दिया गया है? Impedance of the circuit. And that one is denoted by Z. So impedance of this LCR circuit Z is equal to root R square plus XL minus XC whole square. So by using this formula, you can find out the impedance of LCR circuit. One more thing here. From here, what I am saying, in this case, applied voltage V leads the current I by phase angle phi. So from this triangle, this one is a right angle triangle, you can write tan phi is equal to perpendicular upon base. Perpendicular means you will take VL minus VC. Base means VR. So you can write here tan phi is equal to, look here, VL minus VC upon, this one is VR. At place of VL, IXL minus IXC upon, here you can write IR. Or simply you can say tan phi is equal to IXL minus XC upon IR. I is cancelled by I. You can get here XL minus XC upon R. और यहां पे फाई क्या है? अब फेज एंगल, इसका मतलब अप्लाइड वोल्टेज V करंट I से फाई डिग्री लीड कर रहा है. क्यों? क्योंकि हमने VL को VC से ज्यादा लिया है. अगर VC VL से ज्यादा होता तो ये रिजल्टेंट वोल्टेज इधर काम करता, और उस केस में ये फाई क्या करता? अप्लाइड वोल्टेज करंट I से 5 डिग्री लैग्स बिहाइंड करती. तो यहां पे tan phi XL minus XC upon R. And also you know XL is equal to omega L, XC is equal to 1 upon omega C, and here R. So also you can write in the terms of omega L and 1 upon omega C. So you can write tan phi XL minus XC upon R, At place of XL also you can write omega L minus at place of XC 1 upon omega C by R. अब यहाँ पे तीन चीज देखिए, if omega L means if XL is greater than XC or if omega L is greater than 1 upon omega C. अगर omega L 1 upon omega C से ज्यादा होगा then tan phi becomes positive. And when tan phi becomes positive, it means phi is positive. Phi is positive means applied voltage leads the current I by phase angle phi. If omega L is less than 1 upon omega C, अगर omega L की वैल्यू 1 upon omega C से कम है, then omega L minus 1 upon omega C becomes negative. And when this becomes negative, then tan phi is negative. Tan phi negative means phi is negative. Phi negative का मतलब in this case applied voltage lags behind the current by phase angle phi. And third case, when omega L is equal to 1 upon omega C. Omega L is equal to 1 upon omega C मतलब when XL is equal to XC. Then in this case you will get tan phi is equal to 0. And when tan phi is equal to 0, then phi is equal to 0. Phi is equal to 0 means in this case applied voltage and current both will be in same phase. So there are three possibilities. XL greater than XC, tan phi positive, voltage leads the current I. XL less than 1 of XC, it means tan phi negative, it means applied voltage lags behind the current. And when XL is equal to XC, अभी मैंने previous video बताया था कि if XL is equal to XC, then in this case tan phi becomes 0. It means applied voltage and current both will be in same phase. और XL जब XC के बराबर हो जाएगा तो सबसे इंटरेस्टिंग रिजल्ट क्या मिलेगा? Then what is the impedance of LCR circuit when XL is equal to XC? और XL is equal to XC क्या कहते हैं? Electrical resonant condition. तो in electrical resonant condition, the impedance of LCR circuit, इसका मतलब Z की वैल्यू जो LCR सर्किट का इंपीडेंस है, इलेक्ट्रिकल रेजोनेंस की कंडीशन में XL XC के जब बराबर हो जाएगा तो ये क्वांटिटी तो जीरो हो गई, तो Z is equal to root R square, it means Z is equal to R. So this question several times asked in the board exam, what will be the impedance of LCR circuit in electrical resonance condition? And remember this, in this case the current in this circuit becomes maximum. यहाँ पे करंट तब उस समय आ जाएगी I is equal to V upon R. क्यों? क्योंकि इलेक्ट्रिकल रेजोनेंस में ये सर्किट ये तो जीरो हो गया. This becomes root R square. Root R square means R. So in electrical resonance condition, what is the current in LCR circuit? I is equal to V upon R. Simply you can get like this one here. So you can say, so in electrical resonance condition, the impedance of LCR circuit, इलेक्ट्रिकल रेजोनेंस की कंडीशन में LCR सर्किट का इंपीडेंस क्या होगा? इलेक्ट्रिकल रेजोनेंस कंडीशन मींस when XL is equal to XC, और यहां XL is equal to XC करेंगे तो Z is equal to how much here? R. And when Z is equal to R, so in this case the current I is what here? Maximum in this case, but not infinity. Current becomes what here? Maximum in this circuit here. So in this way you can say, and you know when Z is equal to R and condition XL is equal to XC means in this case resonant frequency F is equal to 1 upon 2 by root LC, जो कि हम पहले निकाल चुके हैं LC सर्किट में. और याद रखिएगा what is the electrical resonance condition? तो electrical resonance condition is that condition in which the frequency of applied voltage and the natural frequency of the circuit both becomes equal. और वो वैल्यू किसके बराबर हो जाती है? F is equal to 1 upon 2 by root LC. Actually the use of the electrical resonance, जैसे अगर कोई पूछे भाई ये इलेक्ट्रिकल रेजोनेंस का यूज कहाँ होता है, तो अगर आप ट्रांजिस्टर बजाते हैं, रेडियो जिसपे विविध भारती ये सब सुनते हैं, अगर उसमें देखें तो उसमें एक नॉब लगता है, उसको क्या कहते हैं? वेरिएबल कैपेसिटर. और जब हम उस नॉब को क्या करते हैं? घुमाते हैं तो किसी पर्टिकुलर स्टेशन के लिए जब एफ की वैल्यू 1/2 पाई रूट एलसी की वैल्यू, क्योंकि वहां कैपेसिटेंस लगातार चेंज होता रहता है उसको घुमाने से, और किसी भी स्टेशन से जो भी प्रोग्राम ब्रॉडकास्ट किया जाता है एक किसी पर्टिकुलर फ्रीक्वेंसी पे किया जाता है। जैसे हम कहते हैं सपोज फ्रॉम वाराणसी रेडियो स्टेशन एनी प्रोग्राम इज ब्रॉडकास्ट ऑन ए पर्टिकुलर फ्रीक्वेंसी, सपोज 500 मेगाहर्ट्ज, सपोज पर मिनट हमने कह दिया, ये एज्यूम कर लिया, या एक्स हर्ट्ज पे। अब हम जब उसको नॉब को घुमा करके जब कैपेसिटेंस को वेरिएबल करेंगे और जिस पॉइंट पे एफ की वैल्यू 1/2 पाई रूट एलसी की वैल्यू एक्स के बराबर हो जाएगी, तो ये हो गई क्या उसकी नेचुरल फ्रीक्वेंसी, और ये फ्रीक्वेंसी जो आ रही दोनों वहां पे क्या कराएंगे, इलेक्ट्रिकल रिजोनेंस होने लगेगा, और वहीं पे फ्रीक्वेंसी क्या करने लगी, रिजोनेट करके उस इलेक्ट्रिकल सिग्नल को हम किसमें बदल लेते हैं, साउंड सिग्नल में। तो फाइनली इन दिस वे वी विल यूज व्हाट हियर कंडीशन ऑफ द इलेक्ट्रिकल रिजोनेंस। So but if anybody asks you what is electrical resonance, so electrical resonance is that condition in which the frequency of applied voltage and the natural frequency of the circuit both becomes equal, and the value XL is equal to XC or F is equal to 1/2 by root LC. Now the impedance triangle, this triangle is very helpful for finding the relation for the phase relationship as well as for finding the expression for the impedance. I am not saying only for LCR circuit, but by using this one you can find out the impedance of either LR circuit, CR circuit, or LCR circuit. And how can you find? With the help of LCR circuit. Now you see here, impedance triangle. The impedance of LCR AC circuit is given by Z is equal to root R square plus XL minus XC whole square, just which I have proved. And the phase relationship tan phi is equal to XL minus XC upon R. तो अगर हम एक राइट एंगल ट्रायंगल बनाएं जिसमें इसको हम कर देंगे रेजिस्टेंस R को डिनोट कर रहा है और ये कर दिया XL माइनस XC को, और इनका जो ये रिजल्टेंट है ये है वो इंपेडेंस Z। तो एंड सपोज दिस एंगल इज phi, means this impedance Z with this angle phi with this R. So in this way you can say Z is equal to root R square plus XL minus XC square। इसका मतलब ये LCR सर्किट के लिए मैं बनाया हूं, लेकिन इसकी मदद से आप किसी भी सर्किट का निकाल सकते हैं। कैसे? Z is equal to root R square plus XL minus XC का whole square, and tan phi for this LCR circuit perpendicular upon base means XL minus XC upon R। अब मान लीजिए if you know this formula, this triangle is called impedance triangle. Suppose if the circuit is given LR circuit, वहां पे C नहीं है, तो C नहीं है तो XC वाला टर्म हटा दीजिए, आप इसको हटा दीजिए, तो क्या मिलेगा, tan phi XL upon R, and impedance of the LR circuit Z is equal to root R square plus XL square, which already have proved here. Suppose CR circuit, तो वहां पे L नहीं है, तो L को XL हटा दीजिए और फिर यहां पे लिख दीजिए Z इज इक्वल टू रूट R स्क्वायर प्लस माइनस XC का होल स्क्वायर करेंगे तो XC स्क्वायर आ जाएगा, तो रूट R स्क्वायर प्लस XC स्क्वायर। एंड व्हेन यू विल टेक tan phi for LR circuit, तो tan phi for LR circuit, tan phi LR means C नहीं है तो you write XL upon R। For CR circuit tan phi is equal to minus XC upon R, यहां माइनस साइन बता देगा कि वो phi क्या करेगा, lags behind it with the applied voltage। So by using this relation you can find out the impedance as well as the phase relationship between applied voltage and current for any circuit, either LR circuit, CR circuit, LCR circuit, by any way। And one more term I want to tell you, from this formula tan phi you can calculate cos phi, क्योंकि in next topic I will discuss the power factor, एक टर्म आएगा पावर फैक्टर और उस पावर फैक्टर को डिनोट करते हैं cos phi से, तो इसलिए मैं बता देना चाहता हूं cos phi is equal to from here R by Z, जहां पे R क्या है रेजिस्टेंस और Z क्या है उस सर्किट का इंपेडेंस। सो cos phi is equal to R by Z, and suppose if you want to find out the power factor for LR circuit, तो पावर फैक्टर मतलब cos phi, and not only phi, cos phi, all this term cos phi is called power factor। So power factor we can find cos phi is equal to R by Z। So in the next video I will give you the power in AC circuit, and quality factor. So what topic I have discussed today, please all of you revise this one. This one is very, very important, and please all of you try to solve the numerical problem of this exercise. Thank you.